we got through like a portion of this review on Wednesday in class. We went through page 1 where we practiced graphing a system to find the solution. We did number 4 where we used the substitution method. So remember, method matters. You have to read instructions and you have to do the indicated method. So this test I am grading slightly different than I did before our other unit tests. So my in-person students or online live students that meet at a certain time, we took a unit 1 proctored test, right? So our second test for us is going to be unit 2 and unit 3. Unit 1, when I graded it, it really was just right or wrong, okay? And that was just how it was because it was multiple choice. This one, I will also be looking at your work that you do to make sure you do the indicated method. So unfortunately, like if you don't do the indicated method, I can't give you credit for it because I'm grading method, not just solution. I can't really stress that enough. I know sometimes we might understand one method over the other, but we don't just teach all the methods just to see which one you like best. There's different reasons why you might need to know. So say you go on to trig, you really need to know the substitution method. You're not really going to be using the elimination method all that much after algebra. So you have to know the different methods. Now, if you're working with a 3 variable system, we do that by elimination, right? So that's why we work with that. So on the second page, remember, it took me a little while to find my factors, and really it was because I was not being a very good example. I wasn't listing my factors as I went. I was really jumping around. So if you ever get a really big number, use my example as a learning experience as of what you should not do, right? Make sure you just go through every factor, even though it's a really big number, you would come to it way quicker probably than what I did. I know that my brain is trained more in a different method because that's how I learned it. I teach it a little bit differently. So I did take a little shortcut to find those because I was just bouncing around. Sometimes when we feel like we're on a time limit, that'll happen. And I would just suggest to you, if that happens, that you should stop and go to something else and then come back to it so you can clear your brain. All right. Because that kind of stuff happens maybe a little bit more frequently with this unit 3 stuff. So we didn't finish this. We just found the factors, or did we finish it with you guys? I don't think we did. I kind of have my review a little mixed up. So if we did, I'm sorry, we're going to go ahead and find the y parts, and then we're going to move on to number 8, 9, and 10. Okay. So we're just going to replace our x values that we found, which were these 2 things, because each of those have a y friend, right? So like say you had some sort of sphere graph, that's what this would indicate. If you have an x squared, y squared, it's some kind of circular type graph. And this is a straight line. So we know, I'm not saying that that's the exact equation. You could always go plug that into Desmos, right? And see what it really looks like if you want, because visuals are really fun and helpful. But we're going to plug in to find the y part that goes with that x. So -3 times 39 over 10 plus 20. So I would just type that into my calculator, -3 times the fraction of 39 over 10 plus 20 is y equals 83 over 10. So one ordered pair is 39 over 10 and 83 over 10. So that's one ordered pair that goes with that x. The other, we need to plug in a 9. So we'd have -3 times 9 plus 20. So it'd be like -27 plus 20. So y would be a -7. So we would have our x part was 9 and our y part was -7. And so that would be like the other ordered pair. So you're not just finding x, you would have to find its y pairing or that coordinate to finish solving, to identify like where those graphs would cross. Okay. And I did want to indicate, like, You guys probably recognize this in your homework. Sometimes they tell you, or not sometimes, but like if you have more than two intersecting points, examples like a nonlinear system, for example, they will tell you like put the smaller x value first. So like if you have a fraction, you need to think like that would be kind of like 3.9, which is smaller than 9, right? So you need to make sure you put them in the right box too. A lot of things to really think about. I know you guys know how to see if a number is less than or greater than, but just remember you have those skills. Kramer's rule, I will tell you on the actual test, the paper test that you're going to take, I might have you solve a 2 variable system by Kramer's rule, but I don't really have you solve a 3 by 3 system. I might just ask you to find dx, and that's because it's just really time consuming, and it does, like there's a lot of room for errors when you're working with these matrices. I've already had lots of emails about I don't know what I'm doing wrong, and every time I have to just go really closely and look at their signs for their matrix to see if they set it up right. And a lot of times they may have set their D up right, but then everything else after that, they didn't bring a negative down with their 5 or something. And that's going to make it wrong. And it's really frustrating because it's hard to find that mistake. So like, while some people really like Kramer's rule, you have to be incredibly detailed to make sure you get it right. And we can be, but sometimes those little things are hard to find. So if we're solving this system by Kramer's rule, remember to find our D value. We would take -1, 5, 3, and -2. So our X and Y coefficients. 2 by 2s are a little bit easier than those 3 by 3s to solve with it. So -1 times -2 is a +2, minus 5 times 3 is 15. So remember, we're just taking our downs minus our ups. And so our D value is a -13. So to find your X, we have to first find dx. And that's when we use our totals and then our Y values. So we have -13 as our totals for both of those, but then my Y is 3 and -2. So we're going to take our downs and we're going to subtract our ups. So negative times a negative makes that a +26, minus a negative times a negative makes that a -39. So there's a lot of room for sign errors, which happens, with the best of us. You know your sign rules, but it happens. Okay, so my dx is like taking 26 plus 39, which is 65. But to find x, we would take 65 and divide it by a -13, which would be a -5. But if I were to ask you to tell me just the dx, all you'd have to do is this part, right? So I just want to draw attention to that, because on the actual proctored test, not the quiz might be frustrating because you have a couple that you have to solve using Kramer's rule. But on the actual test, when it comes to a 3 by 3, I don't make you solve the entire system. Okay, I might actually even treat this review a little bit like that today. That way it's just going to simulate what you're going to do on the test. So this is your X value. Technically, if you know X, you could go find Y by plugging it in, and I would be fine with that. To me, you worked with finding your D and your DX, but I'll go ahead and do my DY using Kramer's rule as well. So we would use our X and then our totals when we set this one up. So 3 and -2, -13 and -13. So basically it's kind of switching them around. 3 times -13 is a -39, minus negative times a negative makes that a +26, but we're plugging it in after our minus sign. So really you're adding those together and it stays negative. So that would be like a -65 would be my dy value. So if I asked you to tell me what dy was, that's all I would really need you to do. You wouldn't have to do all of that, okay? But if we were finding y, which we are because we're solving the system, we would divide by that -13. So a negative divided by a negative makes that a +5 this time. So my solution to this system is -5, 5. So we can solve entire 3x3 systems by using Cramer's rule. For time and to help you prepare you, I will just tell you on your proctored test, you'll be just finding dx when you do your Cramer's rule. And so what that means is you don't even have to go find your d. You don't have to go find the determinant of the entire system. Okay, you only have to set up one matrix. So we would do, if I was finding dx only, if those were the instructions and not to solve, which is what this says for now, but we're going to find dx using Cramer's rule. So we would be using our totals, then our y's, then our z's. So my total would be 2, -17, and 18. Then we have 2, 9, and 4, -2, -4, and -5. So I'm going to repeat my first two rows, 2, -17, and 18, and 2, 9, and 4. I don't have my key with me today, so I will try to be really thorough, like you would have to be. When I teach this, I usually have my key because it's just so easy to make a silly mistake. And while you can catch it as I go, sometimes it's hard for me to catch it as I go. But 2 times 9 times -5 would be a -90. Plus 2 times -4 times 18 would be a -144. Plus, this will end up being positive because you just have two negatives. So 2 times 17 times 4 is a positive 136. So those are our downs. And we're gonna subtract our ups. So sometimes they are these big numbers. So we know this will be negative because we only have one negative. So we're multiplying 18 times 9 times 2 is 324. This will end up being not negative because you have one negative. So 4 times 4 times 2 is 32. So -32 because there was one negative. This will end up being positive. So we're taking 5 times 17 times 2 is a positive 170. So we're going to combine these. I'm just going to type in my calculator, -90 plus a -144 plus 136 is a -98. Minus, I'm going to type this into my calculator, 324 plus a -32 plus 170 is 462. So these are both negative. So my dx value would be just adding them together. 98 and 462 would be a -560. Did you guys get that? Since I don't have my key, did you happen to do this one prior? Did you check my math? I hate to make a mistake, but
I got 88.
It is what?
I got 88, but I think I did something wrong.
Okay, let's look at it because really that's where like it's hard because we want to make sure we can find our errors and it happens so frequently. So when you're doing your quiz, you have to make sure we're like super thorough with every sign that we copied down, which I think we did in our given matrix. I checked that first. Okay, and then I want to make sure when I multiply that I have the right sign. So I know this would end up being negative, and 2 times 9 times a -5 is, or divided by 2 times 9 times a -5 is -90. So let's check this one. 2 times a -4 times 18 is also a -144. And -2 times a -17 times 4 is 136. So let's combine those, -90 plus a -144 plus 136 is -98 for that one. So I double checked that. If you are double checking yours, make sure you see what you get. If you find your mistake, let's go do our ups again. So 18 times 9 times a -2 is, there we are. I found my error. I put that as a positive and it was a negative. So this is negative. And then 4 times -4 times 2 is a -32. And -5 times -17 times 2 is a 170. So -324 plus a -32 plus 170 is a -186. So that's minus 186. So this is wrong, but remember minus, we take our downs, minus our ups. My ups was a -186. So I think I probably even said negative when I did this, but I didn't write it down, maybe, right? And so that's really where it's so easy to make a mistake. And so I'm going to tell you, when you take your quiz, I told my Tuesday, Thursday students this, when you take your quiz, you know, it's time. So you're going to feel pressured with time, which is going to make you want to rush, right? And so I would highly encourage you to go straight to Kramer's rule first when your brain is fresh and have a separate paper always for the ones that you're having to solve using Kramer's rule. There's only 15 problems on this quiz, but you know, still think, how long does it take you to do one? It takes a little bit of time, right? So I think you might use a lot of that 90 minutes for this quiz specifically. But like on the quiz, you will have to actually solve using Kramer's rule. And in a second, when I get done with number 10, I'm just going to double check the test one more time to be sure I'm not telling you wrong. But to prepare you for the test, I know there's one that you just find dx. I don't think I have one where you have to solve by Kramer's rule entirely. Just because of time, and it's so easy to make a mistake on it. I like Kramer's rule. I do prefer to do, like if I was given a choice, I would do elimination just because I know how careless I can be sometimes with negative signs. And that's really where it lies. Like you guys can do it. I've had students already send me questions like, hey, I know I'm doing this right. Where am I wrong? And it'll be, again, it'll just be like they didn't copy a negative down when they set up their matrix. It's only that, and that messes up so many things. Here's a word problem. Hank wants to invest $300,000 into 2 different accounts. He's looking at 2 investments, a very safe, guaranteed annuity that will provide 2.5 interest, and a somewhat riskier that's 8.8% interest. He wants to produce $20,000 of interest in a year. How much should he invest? So this is his initial investment. That's the amount of principal he's going to invest. So remember, if you want, you could set up this tic-tac-toe. This is how I set it up for me. It's how my brain works. Remember, principal times rate equals your interest. If you want to know what each of these rows kind of represent and guide you to plugging it in. So your principal is X and Y because you have 2 accounts, but you're going to say you would add those together and it's going to be 300,000. So we're trying to figure out how much this money can go in X and how much of this money would go in Y, and it would total that amount. My rate, if this is 2.5 interest, we're going to have 0.025 and 8% interest is 0.08. So here, we don't put anything here. Basically, we're going to actually show that you're multiplying these together, 0.025x, 0.08y. And here is how much interest you want to make within the year. So that's 20,000. So if you set up the tic-tac-toe, it kind of helps you set up your equations that you're going to use to solve. So we have x plus y equals 300,000 would be one equation, and this other one is 0.025x plus 0.08y would equal that $20,000 that they're gonna create in that year. So, what this indicates, this equation, if you think about it, is how much of this 300,000 is gonna go in the 2.5% account, and how much is gonna go in the 8% account, and then that needs to equal 20,000. Well, we gotta go find how much by using this system. So what we would do is solve it by substitution, or I would, and you can get X or Y by itself. This time I'll just subtract X over. I don't know what I've done in my notes previously, but it doesn't matter which one you subtract over. And I wouldn't put it necessarily in normal descending order, or you might even think slope intercept form, I guess, right now. But I would say Y equals this 300,000 minus X. And so I'm going to plug that into the other equations, Y. So I have 0.025x plus 0.08 times 300,000 minus X equals that 20,000. So we would distribute, combine like terms, solve for X. So 0.025x, and then we're going to say 0.0, I'm going to plug this in my calculator, 0.08 times 300,000 is a positive 24,000 minus, because a positive times a negative will make that a minus 0.08x equals 20,000. So we've distributed, this would be the step we definitely want to combine like terms. It'll be a negative, but you can type it in your calculator. 0.025 minus 0.08 is a negative 0.055x. And then I'll just bring down plus 24,000 equals 20,000. Then we would subtract 24,000 to move this over to the other side. So we have a negative 0.055x equals a negative 4,000. Now we divide by a negative 0.055. Okay, so it should be positive. Negative divided by a negative is a positive, but think about, this is applying to real money. You can't invest a negative amount of money. So if you get a negative, you've done something wrong, right? 4,000 divided by 0.055 is a weird number, and sometimes it's not nice and neat. A lot of times my examples are, but this would be $72,727 point, and we'll just round to the nearest cent because this is money, so maybe 0.27. So it's not exact, but it's an approximate. So we'll get a decimal for our Y value because we have to say Y equals 300,000 minus the 72,727.27. So we got lots of 7272727, right? So we're going to take 300,000 minus 72,727.27. So your Y value is 227,272.73. So thinking about what that means, I probably on a test would make sure it's one that doesn't have an ugly decimal, but it can happen, right? Sometimes you're not going to split money up by exact dollar, but if they're wanting to make an exact $20,000, they may have to have some change in there, because money, you can have change, right? So my X account was the safer 2.5% account, and my Y account was the 8% account. So it's always good to just identify. I mean, they're putting a lot more money in that riskier account than in that safe. And, that just shows you how the higher the interest rate, the more money you'll generate, right? The lower the interest rate, the more time it would need to be in there than a year to really create that $20,000, which is kind of why some people, when they're investing, they split their money up, and maybe they want to secure a certain amount of money in a safer account, but then they're like, man, I need to be aggressive with this money. And maybe they're okay with that if they lose a little money. I would say it's probably generally flip-flopped, where they'll probably secure the bigger amount and play with the lower amount, but that's a It's a business lesson of its own, right? Okay, so that's your unit 3 stuff. I just want to kind of remind you of unit 2. I'm not going to go over this review, but I'm going to remind you that we did do a test review together that you could refer to kind of go back over unit 2. So I'm going to talk about it, and then I'm going to pause, double check that test before I let you guys go today, okay, about that Kramer's rule problem. So unit 2, we reviewed for that unit 2 quiz, but you could use this to review for the unit 2 part or go back over your notes. One thing I cannot stress enough, which I already stated with the solving your system by the indicated method, same thing with quadratic equations. If they tell you to solve by factoring, you need to solve by factoring. So make sure you get everything to the same side and factor. You know, think about like GCF even. Like, can this factor by GCF? Like, go through all your factoring questions when you're factoring. Square root property, that one's always a little bit easier to notice, I think. So make sure you solve using square root property. There's not one where you have to actually solve a quadratic by completing the square, but that's because we do this concept within circles, okay? So that you're not added another problem, you're just going to show that you understand how to complete the square within circles. We learned it here, though, to help us there. Quadratic formula will be another one where you have to use the formula. The formulas are provided on a formula sheet. It'll be on the very back page of your test, so you can tear it off and throw it in the trash when you're done. I don't need your formula sheet, okay? If you don't use your formula sheet at all, please just tear it off before you turn it in and just throw it in the trash, okay? Part 2, there's those other types of equations which relates to those non-linear systems, kind of like this would, but in a sense, I guess. But so solve a polynomial equation. You're only solving for x, though. You don't have to deal with y. Okay. So this one you would solve by factoring and then using the square root property to find the 3 solutions for x. Rational equations, our goal was to remove the denominator first, and then we could work with it way easier after that. So if you don't remember rational equations, go back to your notes, just take a look at that section. I think that's 1-3, but you'll notice when you flip it through your notes. Radical equations, remember you need to get the radical by itself, then you use the inverse operation to undo the radical. But you really have to check, because sometimes you may solve and really that solution didn't really work out. You know, with a multiple choice question or multiple choice type test, there might be this answer and this answer as an option. So just make sure you check your radical equations so that you choose the right one. Rational exponents, if you remember, are letters that are raised to a fraction of power. And so we need to know what 1x means, not x to the partial power, right? So we still just get x by itself, but then we flip and multiply times its reciprocal. So if you do that here, you have to raise this number to that same power that you multiply by. And you're just going to use your calculator. You're just going to type in 27 to the power of 4/3, and it will give you 81. So it's been a little bit since we've seen that stuff, so that's why we're at least just taking a little time to talk about it today, making sure you do take time to look at this before Friday. Then another thing we learned was circles. Number 1, we learned how to pull out the center by taking their opposite signs. Because remember that standard form equation of a circle is like x minus h squared plus y minus k squared, I had to think of the letter, equals radius squared, right? That's going to be given to you with your formula sheet. But because of the minuses, we just take the opposite signs when we identify the x and y for the center, but then we have to square root our number to find the actual radius. Then you're going to do the exact inverse operation and make an equation from knowing the center and the radius. So you're going to have to square your 15 and actually tell me that's 225. So you still use opposite signs to plug those in. Completing the square is used when, I may ask you to just tell me the standard form of the equation or find the center or the radius. You have to, if it's not in standard form, remember this would be standard form. We use that completing the square method to be able to put these in binomial squares, to put it in, this would be called standard circle form, right? So make sure if you don't remember that, star it, go back over that. There is a video of me doing that review, and you could go back and watch that single one in the review, or go back to the lecture from the notes, whichever one. But just make sure you review it a little bit before Friday. Parabolas was a really big part of Unit 2. You know, we spent a lot of time on it. I feel like there's a lot of different things to learn within parabolas. Number one, we know that the graph is a parabola because it's a quadratic, basically a polynomial raised to the second power. So polynomials that are only raised, the highest degree is a 2. Those are always parabola shaped graphs. If your leading term is negative, then we know that that opens down. They didn't ask that, but just going over that with you. But if your leading term is positive, we know it opens up. This one, they're really just asking you to find the vertex. So if it's in quadratic equation form, then you have to use that negative b over 2a. So remember, like when you learned how to use the quadratic equation, we knew that the number in front of x squared was a, and in front of x was your b, and this is your c value. We just don't really need to know c when we're working with vertex. We don't use it, right? So negative b over 2a. So you have a negative in the formula, then you plug in your a. 2 times a negative 1, so that's 4. So that's our x part. So then we just plug that in. This one's a little weird because remember, no matter what x is, it's going to be negative. That's what they're telling us in this formula. So we're not taking the negative with it when we multiply. So we would just type that in our calculator and get 17. So that's our vertex. This would be kind of like that. But this point would be your 417 on the graph. But then there's a lot of other questions that we learn. And so it's good to review what, your vertex really answers so much about anything else about the parabola. The x part deals with your axis of symmetry, which I did down here. Okay, but your y part is really dealing with your max and min or your range. And so your max and min means like if this is opening up, that means that's the very lowest part of that graph. So this would be a minimum, where this one would have been a maximum if we were to graph that one. And then my range is going least to greatest, dealing with your y value, to write that in interval notation. I don't make you graph a parabola yourself, but you are given a graph on the test where maybe you have to find the vertex yourself from the graph, and then you can answer some things from that. So it's not all that difficult, but it's all kind of the same things. You just maybe didn't have to find the vertex first. Maybe you looked at the graph and found its point. And then the last thing that we learned in Unit 2 was how to use tests of symmetry. If asked if it was in the respect to the y-axis or the origin or the x-axis. So that, remember, that's just reviewing, like, am I changing my x value to a negative? Am I changing my y value to negative, or both? So if it's in respect to the y stays the same. We change the x's. If it was in respect to the x would have stayed the same and the y changes. The origin, they both changed. So remember, we're testing to see if it alters the equation or not. If it alters, then it's not in respect to it. If it goes back to exactly how it was after you simplified, that means it's unaltered, so it would be in respect to that. And then the last thing we did was going over composition of functions. We worked with regular functions too that had operations within them, but this was just one that we put on the review. So we would always work opposite of the way you read, from the right to the left, plugging in 5 into the f function. So that's what we did here. And then we got an actual number, since it was just a real number here. And so then we plugged 14 into g, and then we got our value of 62. So if you guys want to look at that for just a second, I wanted to just run across the hall real quick and grab the test just to verify what I told you about the test. And I will tell you, the last test, I kind of like moved things around where it wasn't really in the order that you learned, but this test is a little bit more like in the way that you learned it. So that might help a little bit, kind of refresh your brain as you were going through the units. When I'm looking at this test, I am just verifying that one of the ways that when we were talking about that 3x3 system, right, or the Kramer's rule, you are not going to have to solve this system entirely by Kramer's rule, but I do ask you to find dx. Okay, so you are going to have to solve a system that has 3 variables with elimination method, but I don't make you do Kramer's rule, and that's really because it's just so easy to make mistakes, and I guess I don't think that is entirely fair. So I just do at least one matrix, that way I know you know how to use that with a 3x3 system. All right. And then the last thing I will just say is, in this review, remember my tests are different than what they've been in the past. So like this unit 2 review that we just did, I didn't give you any just plain factoring problems from unit 2. That's because I was only given 50 minutes, allotting 50 minutes for testing in the past for this unit. But this unit now that we're kind of doing it a little bit differently, I do put a couple factoring problems on there. So it wouldn't hurt for you to just kind of flip through your unit 2 notes and just kind of take a look at factoring, because we don't always factor. And they assume, and I assume, that once we learn it, like you will still do all these steps, but when it's not fresh on our brain, we might forget to like look for a GCF, like this one, for instance. We might forget to look for a GCF before we factor this, and we might forget how to slide and divide to finish. So I would just recommend take a look at that, because you are given like one problem where you just have to factor, and you will need to know how to factor by slide and divide and pull out your GCF. Okay, so I'm just kind of telling you those things as a help. So I assume you know it, and I think that stuff that like maybe you didn't have to be told, but I wanted to tell you so that you're prepared. All right, do I have any questions from you guys? Okay, so remember tonight, you have that unit quiz due, your written work